So we took a look at example number one, and again, all that example number one was it was reminding us on how to do multiplication, which I certainly hope we didn't forget, because that's the standard we were just tested on, okay? But the biggest thing I wanted you to do was, again, start to think about going backwards. So today we're officially talking about factoring. I've been talking about it a lot lately. Now we're actually going to do it, okay? So, we're going to talk about factoring using greatest common factors today and Tuesday, and then on Wednesday we're going to talk about other factoring, but here's what I want you to know. The first step in the other factoring is factoring using greatest common factors. So this is never going to leave what we expect you to be able to do. So anytime that it's asking you to factor, it's asking you, first of all, look for a greatest common factor. Now, when it comes to factoring out a greatest common factor, again, last year we did greatest common factors, and we talked about it, blah, 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 and we found ways to be able to find them, but I'm just going to kind of mentally talk about this as we go. So when we're finding a greatest common factor, you need to consider both the number and or variables that are in the problem, okay? And I would not try to do them all at once. We try to do them individually as we go. So, if I'm trying to find a greatest common factor, first of all, I'm going to take a look at problem example 2a. We have a binomial here. I'm going to begin by taking a look at my numbers. What is the greatest common factor between those two coefficients of 8 and 12? The answer is 4. Okay, the largest number that goes into both of those numbers is 4. That's our greatest common factor of our numbers. So, again, our job is to rewrite this as a multiplication problem. That 4 needs to go in front of my polynomial that I'm going to write this out at. Now, the next thing we need to do is you need to look at the variables on those, and you need to ask, first of all, do the terms all have the same variables? And if they do all have the same variable, how many of them do they all have in common? Again, greatest common factor, they must all have them. Well, when you look at example 2a, the first one's got a variable of x, the second one has a variable of y, but they don't both have them. And as a result, there is no variables that they have in common. So in this particular case, the only thing that is my greatest common factor is my number of 4. Okay? So, we found the greatest common factor, but that's not enough. We haven't actually factored it. So when you're factoring it again, you're rewriting this as a multiplication problem. So what you need to do is, usually this would tell us to multiply by 4, so to figure out what's left inside, you just have to divide by 4. So if I divide each of these terms by 4, what's 8x divided by 4? It's 2x. Okay, not just the number, but also the variable. We're going to be left with 2x. And what's 12y divided by 4? 3y. That's what's going to be left in parentheses. And that's it. That's how we factor to begin with. Now, one thing, because I've been working with my first and fourth period about this quite a bit, sometimes we find a common factor, but we don't always find the greatest common factor. So one of the things that I always want to come back and talk to you about is this. Number one, look at the numbers that you're left over with inside your parentheses. I'm not going to tell you that these two numbers always are going to be prime, even though these are. What's a prime number? A number that's only divisible by 1 in itself, okay? These will not always be prime numbers, but they will always be relatively prime. And that was a phrase we've used for the last 12 months. Relatively prime means they have no other common factor other than 1. So here's what I'm going to point out. If I were to be left with this, and obviously it's not in this case, but I'll use this as an example. Let's say I did this problem wrong. And all that I did is I divided them each by 2. You should know right away that this is not a right answer, because both of these numbers are even. And if both numbers are even, they're still both divisible by another 2. You didn't factor out the greatest common factor. So when you're done, a couple things you should look at, but the number one thing is, are the numbers you're left with inside your parentheses relatively prime? If they are, then you found the greatest common factor. And really, again, you're not going to do this because it's going to be way too time consuming, but You could check your answer on every one of these by just distributing this out and making sure you got that. Okay, if I were to say multiply this out, you should multiply and get that as an answer. That's all we're asking you to do is go backwards and undo that as a division problem. Okay? Alright, now letter B, we've got a trinomial. So now you've got to take a look at all three terms and what they have in common. So again, we're going to start just with the numbers. 10, 5, and 35. I know that's a negative 5 because it's a minus. I really don't care about that at this point. 10, 5, and 35. The largest number that goes into all of those is 5. So part of my greatest common factor is going to be a 5. Now, again, you always need to pay attention to the variables as well. So now notice that my first term has 2 x's, my second term has 1 x, my last term doesn't have any. How many x's do they have in common? 0. You might say, well, what do you mean? How many x's did we just say were on the last term? 0 of them. So if it doesn't have any x's, can it have any x's in common? No. So even though the first 2 have x's, my last term doesn't, I'm not able to factor out a variable in this part. Okay? Because remember, if you're factoring something out, you're telling me, don't get too far ahead of C and D. Okay? If you're factoring something out, you're telling me that every term in the original problem had that. Not every term has an x, so you can't pull an x out. But every term in here does have a factor of 5, doesn't it? That's why we're able to pull a 5 out. So, let's pull the 5 out with nothing else, because there is nothing else in common. Okay? What's 10x squared divided by 5? 2x squared. Okay? Minus, what's 5x squared, or sorry, 5x divided by 5? 1 what? 1x, so I'm just going to put an x. And what's 35 divided by 5? 7 plus 7. And my parentheses. Okay, again, here's what I'm going to point out. 2, 1, and 7. Are those 3 numbers relatively prime? Yes. Okay? Here's something else to think about, because again, as I was working with students today during 4th period, sometimes they'd have this, and every term in here would have an x left. Well, then you didn't pull enough out. Okay? Not every term has an x, so I pulled as much out as I can. You might say, Mr. Tompkins, you didn't pull any out. Exactly, because I couldn't. Okay, and again, if you were to undo that and do that as a multiplication problem, you would get what you started with in the problem. Okay, now letter C. Letter C's now got a little bit more to it. It's a binomial, first of all. Begin by taking a look at your numbers. Greatest common factor between 14 and 21 is 7. But that is not your greatest common factor of this entire problem. How many y's does the first term have? 2. How many y's does the second term have? 1. So they all have how many in common? They all have at least 1 y, don't they? As a result, you need to pull out not just the 7, but a 7y. Now, figure out what's left over by doing division. So technically what we're doing here is we're taking 14y squared and we're dividing it by 7y. Have we done these problems before? Yes. Welcome back to unit number 7. Properties, now we're doing the quotient property. We did the product property for the last couple of days. Now we're doing the quotient property. What's 14y squared divided by 7y squared? 2y. And if you're struggling with the quotient property, just think of it this way. 14 divided by 7 is 2. This had 2 y's and you're taking one of them away and pulling it out in front. That leaves you with 1 y inside. Okay? Then, what's 21 divided by 7? 3. Okay? This had 1 y. How many did we take out? We took out 1 y. So how many are left? 0. There's my answer. And again, if you were to multiply that out with those 2 multiplications, you're going to get 14y squared plus 21y. Alright, letter D. Let's again start with numbers first, variables second. 24, 8, and 16 are all divisible by 8. Okay, how many x's are in the first term? 3. How many are in the second? 2. How many are in the third? So they all have at least how many? They all have 1 in common. Okay, here's something I'm going to tell you. Remember how we talked about standard form and how it gave us all of those nice things that you could find at the beginning? Standard form also works really nice with this because you can find something at the end. What do we always put at the end? The lowest degree, don't we? So if I've got all x's in this problem, the one that has the fewest x's is always here, isn't it? So I can't pull out anything bigger than 1x. Okay, same thing up here. Notice, these all were x's. How many x's does this last term have? 0. I couldn't pull any of them out. Now that works if it's in standard form and if you're always looking at just one variable. That doesn't always work if you're looking at multiple ones. But that's just a strategy that I have. Okay? Alright. Now, we're doing division. What's 24x cubed divided by 8x? 3 what? 3x squared. Okay? Pull down your minus. What's 8x squared divided by 8x? Just an x. Okay? And it's a negative x technically. I already put the subtraction down there. Okay? And then what's 16x divided by 8x? 2. So we're going to have a plus 2 here. Now here's another thing, because this will come up. People will make this error. However many terms you have in the original problem is how many terms you should have inside of this when you're done. Okay? And I'm going to give you a quick example of what I mean by that. Let's say that I gave you 12x to the fourth plus 18x to the third plus 6x squared. Okay, what's the greatest common factor amongst 12, 18, and 6? 6. Okay, they all have at least how many x's? They all have at least 2, so I'm going to pull out an x squared. Okay, what's 12x to the fourth divided by 6x squared? 2x to the second. What's 18x cubed divided by 6x squared? 3x. What's 6x squared divided by 6x squared? It is a 1, but a lot of times people will just do that. Because they're like, oh, I pulled it out, so there's nothing there. This is an issue. Because you started with a trinomial, and inside your parentheses you only have a binomial. If you multiply this out, you're not going to get this, are you? What are you missing? You're going to miss this third term. So in order to make sure that you have that third term, you got to make sure that you put your plus 1 at the end of it. So that's something to also think about. Like, however many terms I'm starting with is how many terms should be in my polynomial when I'm done. All right. Now, let's flip it over and take a look at the back. All right. So, we're still looking in E and F with one variable, and then I started to get a little more complex in G and H, and I threw in more. So let's begin with E. First of all, look at the numbers. The greatest common factor between 4 and 24 is 4. So we're going to be able to pull a 4 out here. Okay, how many x's does the first one have? 4. How many does the second one have? How many do they have in common then? 4 and 3, and then they have 2 in common? If the first one has 4, and the second one has 3, they all have at least 3. That's my greatest common factor portion. Wait, what? Okay, with what? So what do you think it should be? Okay, so if I just pull out 1x, will they still all have some x's left over? Yeah. If I just pull out 1x, then that's going to leave 3 here and 2 here, right? which means that I haven't pulled out enough x's. You got to pull out as many x's as you can. Just like instead of pulling out 2, it's not enough to pull a 2 out. You got to pull a 4 out. You got to pull out as much as you can. So we've got to, if the first one's got 4 and the second one's got 3, they all have 3 of them in common. That's why we've got to pull out a 4x to the 3rd power. All right, what's 4x to the 4th divided by 4x cubed? 1 what? 1x. Okay? Again, minus, what's 24x cubed divided by 4x cubed? 6. And there's my answer. Now again, so we understand what we should be looking for. For those of you, if anyone, and it sounds like some of us maybe thought it was just 4x, here's the issue. This tells me that I haven't pulled enough x's out. If every term that has inside my parentheses still has the variable of x, I didn't pull enough out. So you're pulling them out until they have nothing in common. Nothing in common. All right, letter F. 6, 8, and 9. What's the largest number that goes into all 3 of those numbers? 2 divides 9? Nothing. Which means my greatest common factor technically is a 1. But, how many y's does the first one have? How many does the second one have? How many does the third one have? So they all have what in common? 2 y's. I got to pull out a y squared. In this case, my greatest common factor is not a number, but it's the variable portion of it. So the first couple we did on the front page, our greatest common factor was just a number. Then we had some greatest common factors that were numbers and variables. Now we're to problems where our greatest common factor is just a variable. Now, what we're doing is we're pulling 2 y's out of every term. So how many y's are left in the first term? 3. So I'm going to have 6y cubed. Plus, how many y's are now left in the second term? Only 1, so that's 8y. And how many y's are going to be left in the third term? None. So we're going to have minus 9. And that's going to be it. Again, double checking that, multiplying it back through, I should end up with the original problem we started with. Questions on E and F. Okay, G and H. We've got a binomial and then a trinomial. Okay, so in my binomial, that means I'm going to rewrite this with 2 terms inside my parentheses. And in my trinomial, it's going to be rewritten with 3 terms inside my parentheses. So start with the numbers. 12 and 6 are both divisible by 6. Now, you need to look at each variable individually. And it can come from separate terms, as long as they all have the same number of blanks. So how many does the first term have? How many x's? 6. How many does the second one have? How many x's? 2. So how many do they have in common? 2. So we're going to pull out a 6x squared. Okay, but we're not done yet, because we've got an extra variable thrown into this one. Okay, how many y's does the first term have? 3. How many does the last one have? 1. So how many do they have in common? They've only got 1 in common. So out of every term, we're pulling out a factor of 6, we're pulling out 2 x's, and we're pulling out 1 y. So, what's 12 divided by 6? 2. Okay, if we had 6 x's and we pulled 2 out, that leaves us with x to the 4th. We had 3 y's, we pulled 1 out, so that's going to leave you with y squared. Okay, 6 divided by 6 is 1. It had 2 x's, we pulled 2 out, so that leaves me with 0 x's. It had 1 y, we pulled 1 y out, that leaves us with 0 y's. So as a result, it's just a plus 1 at the end of it. That's my answer now in factored form. Alright, I want you guys to try H now on your own. Factor your trinomial and see what you come up with. Alright, 50, 10, and 35 are all divisible by? They are? 35 is divisible by 10? Nope, they're all divisible by 5. Alright, now you're going to hear me phrase it like this quite a bit. What is the most number of x's, the greatest, that every term has? 1x. So I'm going to pull out 1x. What's the most number of y's that every term has? 2y's, so we're going to pull out a y squared. Then we're going to figure out what we've got left over. So 50 divided by 5 is 10. Okay, 3 x's, you pulled 1 out, that's going to leave you with 2 x's here. 2 y's, you pulled 2 out, so there's no y's left over. Plus 10 divided by 5, which is 2. 2 x's, and again you pulled 1 out, that leaves you with 1 x there. It had 2 y's, you pulled 2 y's out, there's no y's left in that second middle one. Plus 35 divided by 5, which is 7. It had an x, you pulled it out. It had 2 y's, you pulled 2 y's out. Nothing's left at the end. There's your final answer. So again, here's things to be looking for. 10, 2, and 7, number 1. Those 3 numbers are relatively prime. Okay? Also, none of the terms have all x's or all y's. Because again, if I would have had a y here, here, and here, I didn't pull enough out. If I have an x here, here, and here, I did not pull enough out. So if you pulled everything out, then none of the 3 terms should have the same variable at the end of it. None of the 3 terms should have a common factor of it as well. Alright, one last one that I want to throw on here. Okay, and I realize for me that I need to make sure that I include this in my notes for next year. Example I. There's one of these when I looked at your homework tonight that I want to talk about, because this is a habit I want you to get into. Okay? 90% of the time, I don't ever worry about a greatest common factor, like I just pull out my number and I move from there, and I don't worry about the signs inside the problem. Except this. If my leading coefficient is negative, I want us to adjust that a little bit. Okay, and I'm going to show you how. So, what do I mean by leading coefficient? The number that's, no, not just in front of the x, the number that's in front of the whole polynomial. Our leading coefficient is the first number you look at when the answer is in standard form. Okay, when it's in standard form, we want to be looking at that. Okay? Now I'm going to throw up one that's a little wonky. I'm going to throw in a couple different ideas here just so we can talk about it. So, we're going to go with negative 7 x squared y cubed, okay, plus 10 xy squared, okay, minus 3x squared y. Okay, last I checked, that is in standard form. We got a degree of 5, degree of 3, degree of 3. So first of all, look at your numbers. 7, 10, and 3. Greatest common factor among those three is 1. Now, because your leading coefficient is negative, you'd like to make that into a positive. So what does that mean? We're going to factor out the number-wise. We're going to need to factor out, because it doesn't have a number, like my greatest common factor we just said was 1, but if I want to get rid of that negative and make this positive, I got to pull the negative out, don't I? So I'm technically going to pull out a negative 1. Now, what is the most number of x's that every term has? They all have, the middle one doesn't have 2 x's. The middle one's only got 1 x. So we're going to pull out 1x. What's the most number of y's that every term has? 3 y's, 2 y's. This has only got 1 y, isn't it? So I only can pull out 1 y. So the way you'll see this written in the book, they won't put the 1 there, they'll just write it as this. That makes sense? Now figure out what's left over. Now think about this. We emphasize this a ton. When you multiply through by a negative, what did we say you always have to do? Change all the signs. So guess what happens when you divide by a negative? You're going to change all the signs again. So what's negative 7 divided by negative 1? Positive 7. Okay, if I pulled out 1x and 1y, that's going to leave me with xy squared. Does that make sense? Okay, what's 10 divided by negative 1? Negative 10. We're switching that sign. If I pull out 1x and 1y, I'm left with just a y. Negative 3 divided by negative 1 is a positive 3. If I pulled out 1x and 1y, I'm left with just 1x. Now here's what I'm going to point out. Some people are like, Mr. Tompkins, they all have variables, yet didn't do it enough. No, that's not what I said. If they all have the same variable, you didn't do enough. Do they all have x's? No. Do they all have y's? No. I couldn't pull anything more out variable-wise. Even though this has, all three of these terms have a variable, they don't all have the same one. This is in factored form. So there is one problem on your homework tonight. And again, this is a good habit for us to get into when we build into this next Wednesday. If your leading coefficient is negative, then not only are you factoring out the greatest common factor, but you also want to factor out a negative with that as well. We are looking for this leading coefficient inside. We're looking for this to always be positive. It is way easier if it's positive. It's not nearly as easy when this is negative. Okay? Questions? Homework for the weekend, and this will be due on Tuesday, so you've got 72 hours to procrastinate, but it needs to be done. Okay? Page 520. Numbers 17 through 24, and then also 40 through 45. Just a quick reminder that on Tuesday we will check homework, and then I've got a review worksheet that's going to review all of this, because this skill is not individually assessed. This skill will be assessed within 8-4, 8-5, 8-6, 8-7, all of that stuff put together. Okay, Carla? This itself will not be tested, but I will tell you that you can't do the next check until you can do this.